Alright, let's take a look at problem number 1, copper sulfate, and let's find the oxidation numbers. First things first, hey, let's break this thing apart into its pieces. Copper sulfate is going to be made up of copper 2 plus ion and sulfate 2 minus ion. How do you know? Well, this is a metal and a few nonmetals, so you know it's going to be an ionic compound with a polyatomic ion. So you know that copper sulfate is made up of Cu2 plus and sulfate. If you forgot the charge, check your periodic table. Which is nice because that gives us the oxidation number for copper because it's going to be the same as the ion that it normally is, and it's copper 2 plus. So plus 2 for copper. Now to figure out sulfate, let's break it down a few pieces here. Maybe I'll just do it right here. Sulfate, SO4 2 minus. The oxidation number for oxygen is -2 because that's what it is unless it's a peroxide. A peroxide is when it's HOOH, it'll be -1. But you'll know when it's a peroxide because right now it's not. I'll tell you. So here it is. Here's sulfur and here's oxygen. Since oxygen is -2, 4 times 2 is -8. The total charge has to equal, or I guess the total oxidation numbers has to equal the charge of the molecule. So this is -2. So what number does S have to be? That's right, +6. So it's +6. Notice how I wrote -2 as the oxidation number for for oxygen, not -8. It's not the total, it's per atom. So really, if I looked over here, all right, -2, because I circle it, and +6. Okay, there it is. Let's do the second one. B, potassium permanganate, KMnO4. This is a lot like the last one. Let's break it down. We know it's an ion, so here's K plus, and this is manganese. Sounds like I'm complaining about my knees, but they're okay. So since it's K plus, the oxidation number is going to be the same, +1. And MnO4, let's break that down over here. MnO4 minus, the oxidation number for oxygen is -2. Always start with the ones you know and then figure out the rest. 4 times -2 is -8. The total has to be the charge, which is -1. And so what number does this have to be, kids? That's right, plus 7, just like Dora the Explorer. So here it is. This is +7. This is -2. Okay. Let's go to the next one. FeCl2. And this thing had 2 pieces to it, naming it and then finding the oxidation numbers, which are related. So here we go. Here, this is Fe, and we know that each Cl has a -1 charge. So what does this have to be? Fe2 plus. Okay. So let's name these darn things here. Alright, the name of this ion is iron 2, and the name of this one here is chloride. So this is iron 2 chloride. And the oxidation numbers are the same as their ions. So +2 and -1. Notice I didn't write -2, I wrote -1. Okay. Thank you, Darren. You too. He was just working on a test. Oh, the last one. Iron 2 nitrate. Let's break that down into its ions. Iron 3, we know that that's Fe3 plus, and nitrate, remember nitrate, not nitride. Look at the periodic table. Anytime you see 8s and ites, those are probably polyatomic ions. When I say probably, they are. So this is nitrate. How many of these do you need to balance the charge of this Fe3 plus? That's right, kids, 3 of them. So the formula is FeNO3, 3. Let's find the oxidation numbers for all this stuff. So Fe I'm sorry. We know that For FeNO3, this is now plus 3 because we figured out the charge. Well, they told us what it is, iron 3. If not, we could have figured it out from here anyway. Let's figure out the charge for each of these. So let's break down nitrate into its individual pieces. NO3 minus. There's 3 of them, but we only need to, they're the same 3, so we need to just do each atom at a time. So oxygen is -2. Okay, and since there's 3 of those, that's -6. The total has to equal the charge, which is -1. So what does this number have to be? That's right, kids, +5. So nitrogen is +5. And you can just write it up here, +5 -2. Notice once again, I didn't write in -6, I wrote -2 because it's per atom. Okay, hopefully that helps. Good luck. Try the rest on your own.